In this demonstration, I'll have a look at the type 2 rational function, and you can see that f(x) is x plus 3 over x minus 1. We can continue in the same sort of way that we did with the type 1, and what we'll do is just add a few extra bits to it. What you'll have to remember is what we saw in class, the idea of dividing all four parts of the function by x, and we'll see that in a moment. So what can we do? We can do the y-intercept. I think that's probably the first thing. Okay, obviously that is when x is 0, so that will imply that y equals 0 plus 3 over 0 minus 1, which is negative 3. So we have the point 0, negative 3 as the y-intercept. Let's go with the intercept, see if there is one, and that occurs when y equals 0. So now what we're going to have is 0 is equal to x plus 3 over x minus 1, and what we said before is that the x minus 1, this part here is dividing, so we need to take to the other side and it will multiply. So this will give us 0 times x minus 1 equals x plus 3. Okay, something's gone wrong there. There we go. Excuse me, things are going a little wrong. Anyway, where were we? Is x plus 3. So we've got 0 equals x plus 3, which implies x is negative 3. So what we have there is we have an intersection point from minus 3, 0. So that's the x-intercept. Okay, let's have a look at the next easiest, which would be the vertical asymptote. And from this we can see what we're looking for is we're going to put x minus 1 equals 0. So the denominator cannot be 0. And when that happens is when x equals 1. So that will give us the vertical asymptote. Horizontal asymptote we're going to, on this case, going to do the fancy little bit that we did in class today, which was taking our 4 pieces of the function and dividing it by x. So if we divide all 4 of those by x, we saw that that would still give us a true statement. There's nothing wrong with that. And so we now have x divided by x is 1. So we've got 1 plus 3 over x. And then on the bottom, on the denominator, we've got x over x again, which is 1 minus 1 over x. Now, as I said, don't be worried about that too much. It looks messier. It looks worse than what it was. But what we're trying to do for the horizontal asymptote is trying to look at the behavior of the graph far to the left and far to the right. So let's set x going to infinity. So as x goes to infinity, y will go to 1 plus, now 3 over something extremely big is 0. 1 minus 1 over something extremely big will be 0, which equals, implies that y will tend to 1 over 1, which is 1. That is our horizontal asymptote. Alright, so let's have a look what we've got so far. We have an x and a y axis. We have 2 intercepts, 0, negative 3, and negative 3, 0. So we've got 0, go down to negative 3, let's say that's about here, and we've also got -3, 0, which is another point of intersection. We have two asymptotes this time. X equals 1 is our vertical asymptote, which will be around there somewhere. So that's x equals 1. And we've also got y is 1 as well. So y is 1 would probably be somewhere about there. Don't put a sketch, but make it a reasonable sketch so that it does make sense. Okay? Now, as we've talked about before, the graph itself cannot cross a vertical asymptote. So what we have here is the curving graph here. It's got to go through -3 in both places here, and it can't cross over the asymptote. Okay, so we'd have something like that. All right. Now another check on that, another checkpoint for that. We'll have a look in a minute. In fact, no, we'll do it now. What we can do is we can have a look at the number line again. What are the important points? We've got -3. All right. We've got 0, where we have the intercept. We've got 1, where we have our asymptote. So when x takes those values, y, well, let's have a look. When y is 1, when x is 1, y is infinity. All right. When x is 0, y is -3. And when x is -3, y is 0. Now what we're going to do is we're going to look at the places in between those, if you like. What the graph has done is chopped the x-axis into 4 pieces. So let's have a look. What will happen to y when x is bigger than 1? Okay. Well, when x is bigger than 1, what we will have here, oops, forgotten what we're doing, x plus 3, x minus 1 equals x plus 3, x minus 1. Okay. What we're going to have a look at here is the different values. So when x is bigger than 1, let's say 2, then what we have on the top is 2 plus 3 is 5, 2 take away 1 is 1, we have positive over positive. Alright, so when x is bigger than 1, y is going to be positive. So what we can put on here is that section will be positive. Okay. When x is between 0 and 1, okay, no, that's a fraction. Don't worry about that. Let's just have a quick look. Let's say a half. So when x is between 0 and 1, let's choose a half. Then we've got a half plus 3 is positive, and a half minus 1 is negative. So we've got positive divided by negative, so y must be negative. That's that for section there. All right. Let's have a look when x is between -3 and 0. That's the next section. So let's say, I don't know, -1. So what we're going to have is that y is -1 plus 3 is positive. -1 minus -1 is negative. Positive divided by negative is negative. So between that section, it's negative. And when, looking at the fourth part, when x is less than -3, let's say -4 for example, we have -4, add 3 is -1, -4 take away 1 is -5. So we've got -1 over -5, which is positive. Okay. Now if you look at those 4 sections and compare it to the actual graph, Let's go from left to right. What we have is y is positive after minus 3. Well, you can see that's happening, look. There, look. But of course, it's got the asymptote there. Okay. Let's have a look again. Let's have a different colour. Between minus 3 and 0, we've said it's negative. Well, between minus 3 and 0, look at the graph. The y values are all below the x-axis. All those are negative. Take another colour. Green. And which says between 0 and 1, the y values are negative, which they are. And then the last bit, what we're going to do is we're going to say that after that they're positive. So the graph must be something like that. And that is, you'll notice that all the y values are positive there. That's it. We're done.